Hello everyone, my name is Hadi Yornadi from 1IPAB. Today I will be present about Newton's law of motion. First of all, we will discuss about the story of Sir Isaac Newton. Sir Isaac Newton is the founder of motion law. Sir Isaac Newton born in 1943 in Woolsthorpe, England. He is also English scientist and mathematician. Isaac Newton is best known for his theory about the law of gravity, but his Principia Mathematica 1686 with its three laws of motion greatly influenced the Enlightenment in Europe. Today, these laws are known as Newton's law of motion and describe the motion of all objects on the scale we experience in our everyday life. The first law of motion. The first law of motion, or that is known as the law of inertia, states that a body to remain at rest will remain at rest, and the body in motion will continue moving at a constant speed in a straight path unless an outside force will act on it. What does this mean? Basically, an object will keep doing what it was doing unless acted on by unbalanced force. If the object was sitting still, it will remain stationary. If it was moving at a constant velocity, it will keep moving. It takes force to change the motion of object. Example of first law of motion. When we roll a ball on the surface, it will come to rest due to friction and air resistance. If these forces do not oppose, the ball will continue to roll. The second example. A bicycle stored 5 years ago in a lost comes out in its inertia when a child decides to use it. They will not change their position until an external force acts on it. In this case, the child decides to change the bicycle position. The second one is second law of motion. The second law of motion, or that is known as the law of acceleration. Newton's second law of motion pertains to the behavior of objects for which all extrinsic forces are not balanced. The second law states that the acceleration of an object is dependent upon the two variables: the net force acting upon the object and the mass of the object. Acceleration of an object depends directly upon the net force acting upon the object, and inversely upon the mass of the object. As the force acting upon an object is increased, the acceleration of the object is increased. As the mass of an object is increased, the acceleration of the object is decreased. The formula of second law of motion are delta F equal to mass times acceleration. What is accelerate? Accelerate is an unbalanced force cause something to accelerate. A force can cause motion only if it's met with an unbalanced force. Force can be balanced or unbalanced. Depends on the net force acting on the object. Net force, the sum total and direction of all force acting on the object. Net force always causes acceleration. Here are two more examples of accelerate formula. Next, what does F equal to mass times acceleration means? Force is directly proportional to mass and acceleration. Imagine a ball of a certain mass moving at a certain acceleration. This ball has a certain force. Now, imagine we make the ball twice as big, double the mass. By keep the acceleration constant. F equal to mass time acceleration says that this new ball has twice the force of the old ball. Now imagine the original ball moving at twice the original acceleration. F equal to ma says that the balls will again have twice the force of the ball at the original acceleration. Examples of second law of motion. Second law of motion, we got smaller the mass this is, larger the acceleration. And opposite, larger the mass, smaller the acceleration. We got example, a small car and a large tank. A small car got a large acceleration and the big tank got a small acceleration. These are the sample number 1 of the second law of motion. What acceleration can a person produce when pushing a law mover? Suppose that the net external force exerted on a lawn mover is 51 Newton parallel to the ground. The mass of the mover is 24 kg. What is the acceleration? F net equal to mass times acceleration. Acceleration equal to F net divided by mass. Acceleration equal to 51 divided by 24. We got 51 from here. It said in the question 51 Newton parallel to the ground, and the mass of the mover is 24 kg. And we divided A equal to 2.1 meter per second square. A 50 Newton upright force dragged an 8.16 kg log to the right across a horizontal surface. What is the acceleration of the log if the force of friction is 40 Newton? First, we write the formula. F net equal to mass times acceleration. We got F net 50 Newton divided subtract by 40 Newton equal to the mass 8.16 A. 50 divided subtract by 40, we got 10 equal to 8.16 A. We divide 8.16 by 10, and we get A equal to 1.23 meter per second square. Sample problem number 2. An elevator with a mass of 2000 kg rises with an acceleration of 1 meter divided by per second square. What is the tension in the supporting cable? F net equal to mass times acceleration. T subtract by mass times gravity equal to mass times acceleration. The tension equal to mass times acceleration add by mass times gravity. Tension equal to 2000 times 1 plus 2000 times 9.8. The tension we got is 21,600 Newton. These are the sample problem number 3. Mass of object is 1 kg. The net force are EF equal to 2 Newton. Determine the magnitude and direction of the object acceleration. First of all, we write again the formula. EF divided by mass. A. EF we got 2 Newton here, we write down here 2, and the mass is 1. And the acceleration we get is 2 meter per second square. Now we determine the direction. The direction of an acceleration equal to the direction of the net force. The third one is third law of motion. For every action, force in the nature, there is an equal and opposite reaction. If an object A exerts a force on object B also exerts an equal and opposite force on object A. Example: Example is when you jump, your leg applies a force to the ground, and the ground applies an equal and opposite reaction force that propel you into the air. Example of third law of motion. What happens if you are standing against the wall, pushing the wall? You can stand still because when you push the wall, you are giving force to the wall, and the wall gives back the same force to you, causing you can stand still against the wall. Why does the boat go backward while the girl jumps to the shore? Because when the girl jumps to the shore, she pushed the boat, giving it force, and the boat gives back the same force, pushing the girl forward to the shore. Example of third law of motion in real life. What happens if you are standing on a skateboard or a slippery floor and push against the wall? You will slide in the opposite direction away from the wall, because you push on the wall, but the wall pushes back on you with equal opposite force. The second example are: many people are familiar with the fact that a rifle gun recoils when fired. This recoil is the result of action-reaction force pairs. A gunpowder explosion creates hot gas that expands outward, allowing the rifle push forward on bullet, and the bullet push backward upon the rifle. These are the sample problems. John has a mass of 40 kg. Then John pushed the wall with a force of 200 Newton. So the reaction force exerted by the wall on John is equal to F action equal to negative X reaction. The X action are, we get from the question, 200 Newton equal to negative F reaction. Newton equal to negative 200 Newton. F reaction equal to negative 200 Newton. The sample problem number 2. The diagram below shows a particle act on by a set force. Given that the particle is at rest, find the value of P and Q. The first one goes up 4Q, the right one P, the left one 150 Newton, and the bottom one P plus Q. We get here P equals to 150 Newton because the right and the left are same, and opposite, the top and below are same, and 4Q equal to P plus Q. 4Q equals to P plus Q, and we got the P 150 Newton. 150 Newton equals to 4Q subtract by Q. We got 150 Newton equal to 3Q. Q are equal to 50 Newton. But this is not the answer, because the question is asked for the value and P and Q. We must write the value P and Q. We get right here. P is equal to 150 Newton and Q are equal equal to 50 Newton. Thank you for your attention today.